Hey guys, in this video I'm going to share with you a cool Terraform configuration which builds a complete infrastructure on AWS. The Terraform configuration I would provide you is going to create a VPC, two subnet, internet gateway, checkpoint management server, a checkpoint CloudGuard gateway. It's also going to create an internal server. You would be able to choose how many internal servers you would like to deploy. Create three route tables, internal, external, and ingress route table. And I will explain the routing later on. And if you would like, you would also be able to deploy an external servers on additional external VPC. At the end of the deployment, the Terraform would run a script against the checkpoint management server and would configure the gateway object in the management, create a SIG with the gateway, and install a policy on the gateway. And if you already have a management up and running somewhere else, you would be able to choose to deploy all the other parts but the management, and the script would work against your existing management, and your existing management can be located anywhere on-prem, on a different cloud provider. It doesn't really matter. And all of this process would take no more than 15 or 12 minutes. So you can run the script, go grab a cup of coffee, and once you back, the environment would be up and running. Isn't that cool? So before we run the script, there are some pre-requirements. First, you will need to download the latest Terraform version. So go to Terraform website and download the latest version. Extract the zip file. And now I will add the Terraform directory to the system variables, so you will be able to run it from any directory. Now the second requirement is an OpenSSH software on your Windows machine. If you are using a Linux, it's already there. The Terraform will need an OpenSSH as it's going to connect to the checkpoint management over SSH and run the configuration script. So I will download the OpenSSH from GitHub. You can download it from other source and extract the files. And again, I will add the path of the OpenSSH folder to the system variable, so I will be able to run it from any location. The third requirement is that AWS key pairs for connecting to your EC2 instances will be in a PEM format. So if you create a new keys from AWS console, you can create them in PEM format. But if you already have a key in a PPK format, like I do, it's not a problem. Just open a PuTTY-gen. You can upload the PPK keys, your existing PPK keys, and export it to a PEM file format. The last requirement is to generate an API key on AWS console, so the Terraform would be able to connect to AWS API and run the deployment. So open the AWS console and navigate to IAM service. Create a new user, or click on existing user that has sufficient privilege, and then go to the security credentials and create the access key. Don't forget to copy to Notepad the access key and the secret key. And basically now we are ready to move on to the Terraform script. So download and extract the Terraform zip file. The Terraform zip file is attached to the post on Checkmates. So download it from there. And now we need to locate the PEM private keys and copy to the keys folder on the Terraform folder, Terraform configuration folder. There is a key folder, copy it to this location. And you will need to set the appropriate NTFS permission. It's too permissive by default. You need to make sure that the NTFS permission are restricted and only the user that is currently authenticated to the Windows machine, the one that is going to run the Terraform script, would have read permission on the key. The Terraform script will fail on an error claiming that the private key permission are too exposed if you would not do that. So set the NTFS permission. And now open in Notepad++ or any other editor the Terraform tf-vars file. I will copy and paste from the Notepad the access key and the secret key for AWS API access. One important note before we move forward: on the latest Terraform configuration script, we've added support for deploying not just a single gateway, but also a cluster. In the new Terraform TF-vars, so make sure that you are using the newest one, you will find a new parameter at the bottom of the file, gateway solution type, and it can get one of the following two values, single or cluster. So make sure that you are using the latest one. I will set the region in which I would like to perform the deployment. If you don't know what is the region parameter name, you would find it in the following link. The username is the name that each instance name will start with. We are going to deploy few instances, so you will find after the deployment the name will start with the name that you will provide here. And the project name is also going to be attached to the name, so the name of the instance is going to be the name, the username, and then the project name, and then the instance name. The key name as it's shown on AWS console. The Keypass, we put the key file in the keys folder, so just change the name of the file to reflect your own key file name. The gateway type is the AWS instance machine type. Feel free to adjust it to your own needs. Just bear in mind that not all instance types are supported. We have an SK that explains exactly which instances are supported for each CloudGuard version. The gateway version, I use the latest one, R8110. The gateway password hash is the password that would be used to access the Gaia portal. The value here represents the password that you see on the screen. You can use this one and change it later on, or you can replace it right now. To generate a password hash, just log into any Linux machine and run the command open SSL passwd-6 and then put the password, and you will get a hash for this password. The external and internal instance types are for the servers that would be deployed on the external VPC and on the internal VPC. And the count is for the number of servers that would be deployed for internal and for external. Management import, the value here can be true or false. And as we choose to deploy the management server, we will need also to set the instance type. Make sure that you put here an AWS instance type that is supported. The management version needs to be at least the same version as the gateway that is supposed to manage. And of course, the password hash, which is going to be the password for the Gaia portal and also for a Smart Console. In case you choose to use an existing management and you would set the value of the management import to true, this part can be ignored as the management already has a password, so you don't need a hash. And you will need to provide the IP address of the existing management server and also the path for the private key of the management. And again, it's need to be in a PEM format. For the ease of use, place it also in the key folder. So now we are done with the preparation phase and we are ready to run the script. So open the command prompt, change the directory of the Terrafrom configuration directory and run the command. And the first command that we are going to run is Terrafrom init. It would initialize the working directory containing the Terrafrom configuration file and also download the AWS and Checkpoint plugins that are required. It's going to take a few moments. The next command is the Terrafrom apply auto approve, which would actually start the deployment process. In our case, it's going to take something like 12 minutes. If you are using an existing management, it's going to take like 5-6 minutes. So 12 minutes has passed, and in the output we get the IP addresses of all of the instances, the management, the gateway, and if we choose to deploy also in internal and external servers, we are going to get the IPs as well. I will open a smart console and connect to the management machine. The username, as always, is admin, and the password is the one that you set for the password hash. The default rule that we have set is any except. So move forward and change and set the rule that you want. And I will switch to the log viewer, and while it's loading, let's connect over SSH to one of the internal instances. The internal instance is a public IP, as you can see, but all the ingress and egress traffic to the internal instance is routed through the CloudGuard gateway. As we use AWS Ingress Route, as you can see, we have three tables that are associated with the internal route tables that are associated with the internal VPC. The internal route table route all the traffic to the internal interface of the gateway. The external route table route all traffic from the gateway to the IGW, the AWS Internet Gateway. And the ingress route table is associated with the IGW and is routing all the incoming traffic to the external interface of the gateway. So routing configuration, this routing configuration will make sure that all ingress and egress traffic goes to the CloudGuard gateway. So now I will open SSH to the internal server. I will access the public IP machine of this instance, and it should be routed through the gateway. And I'm in. And now I will ping from this instance to Google DNS, so to external service. And let's check in the logs to see if we see both logs for the ingress and egress traffic. And if we see both logs, we can understand that all the traffic in and out is going to the gateway. And we are all good. We see both logs. So basically, we are done. Guys, I hope that, this Terraform script, this configuration would be helpful and beneficial. We will publish more configuration templates with cluster and autoscale soon, so stay tuned, and thank you and see you soon. Bye bye.